you want to know these definitions, and you'll get these things down because you're going to use them so often. And then the reciprocals are the same. The tangent and cotangent are reciprocals. Cosine and secant, sine and cosecant. Okay, so those are what we would call the circular definitions of the trig functions. Okay, and what I was showing you down here in the bottom is that they all are the same from that definition. Okay, so let's see. The first thing I want to show you how to do down at the bottom of the page is if you have a point on a circle, that's just some point, then you can think of that as a point on a circle. We can find the values of the 6 trig functions easily by doing this. So basically I'm giving you x is -3. I'm giving you y is 5. So you got to find r. Okay, well the way you find r, and remember what you really have is you have a point on the circle, which is like this, -3, 5. So what it really means is this value is x, that value is y, that value is r. So how do you find r? You do the Pythagorean theorem, right? So what you have is r squared is equal to x squared plus y squared, okay? So we'd end up getting r squared equals -3 squared plus 5 squared. So that would be 9 plus 25. So that would be r to the second equals 34. And then you can square root both sides, so you would get r is root 34. So anytime you have a point, then you know x and y automatically. You find r with the Pythagorean theorem. Okay, you with me so far? Okay, like I said, use Pythagorean theorem and trig all the time. All right. Now it's just a matter of applying the definitions. So, and I'm going to use these definitions. So the sine, let's start with the sine, cosine, and the tangent. That's usually what I do, is just do sine, cosine, and tangent, and then do the reciprocals to find the other ones, okay? And you do have to rationalize denominators sometimes. So the sine would be 5 over square root of 34. Okay, you can rationalize in your head. I mean, students always get to a point where they just start doing that in their head. So you don't want square roots in the denominator. We've talked about that. So the answer would be 5 square root of 34 all over 34. So that's what the value of the sine is when you have that particular point. Okay. The cosine is x over r. So x is -3. R is square root of 34. So again, you could just rationalize that denominator. Just do that in your head if you want to. Okay, so that would end up giving -3 root 34 over 34 like that. Okay, and then finally the tangent. The tangent is just y over x. So y is 5. X is -3, so it's a negative answer. Just put the negative either in the numerator or in front of the fraction bar. It doesn't really matter as long as you got a negative answer. Okay, so there's nothing to that. You're just applying the definitions. And that goes like this. The cosecant's r over y. So r is square root of 34. Y is 5. Okay, that's just the reciprocal of the sine. The secant is r over x. R is square root of 34, x is -3. You can write it that way. I prefer that you write that as just put the negative in the numerator. That's a matter of preference, okay? And then the cotangent is x over y, so that's -3 over 5, okay? So that's an exercise to help you learn your definitions and understand that what you really do when you get a point, you really get an angle theta. We don't know what that angle theta is. It doesn't matter, but those are the 6 trig functions that you get then. Okay, does everybody follow what I did there okay? Okay, so x and y are given. R is Pythagorean theorem. Apply your definitions. Rationalizing, everybody okay with rationalizing and that kind of thing? Because you're going to do it all semester. Okay, just don't want to have any radicals in the denominator. Okay, all right, I'm going to have you guys crunch this one out. It's the same thing, just give you a little opportunity to practice this. I'll write down the definitions on these two since you're just now learning these things. So go ahead and take the point -4 or 4, -1, find X, Y, and R, and then see. I'll give you a couple minutes to see if you can put this together okay. So you should be getting root 17 for R. Is that working? Okay. All right, that's your Pythagorean theorem. And then once you get the R, it's just a matter of plugging them in. So let's see, the sine is y over r, so that's negative 1 over root 17. And be sure to rationalize that. So you should get negative square root of 17 over 17 for sine. Cosecant's r over y, so that should be just negative root 17 over 1, or negative root 17. Cosine's x over r, so that's 4 over root 17. Again, rationalize. I don't care if you don't write the step on rationalizing a denominator, because it's easy enough to do in your head. So that's what you get for cosine. And then secant is r over x, root 17 over 4. Okay, tangent's y over x, so you should get negative 1/4. Cotangent's x over y, 4 over negative 1 would be negative 4. Okay, that's it. Nothing to it. As long as you know the x, y, r definitions of your trig functions can rationalize, you shouldn't have any trouble doing that. Okay. Questions on that? Is that good? Okay. All right. Okay, I'm going to go ahead and next thing we're going to talk about is reference angles and what they mean and how to compute a reference angle. There's reasons that you want to learn reference angles because ultimately it helps you find the values of the trig functions at different places. So first of all, I'm going to show you what we mean by a reference angle. Reference angles formed by drawing an altitude from the ray where the angle terminates to the x-axis. That's the key, is you go to the x-axis. All right, so this diagram shows that pretty well, I think. And then I'll begin on the next page to kind of show you what we're doing with this. So if you're in quadrant 1, what happens is you always make a triangle, so you always go straight down like this. And this is a good thing to write. You don't have to do this on your notes, but you can if you want to. You end up just getting x, y, and r. And then that ends up being your reference angle. We usually use a prime. Okay, that just means that's the reference angle, okay, in that case. So the reference angle is the same as the quadrant 1 angle that you're given. If you go to quadrant 2, then what you would do is just go straight down to the x-axis. Again, you always go the x-axis at a right angle, like that. This would be the x value. That would be the y value. That would be the r value. And then that would be theta prime. That's your reference angle. Okay, so the reference angle is between the x-axis and wherever the original angle ends. Okay. When you go to quadrant 3, okay, you're going to go straight up to the x-axis, and then this would be x, that would be y, that would be r, and then that would be theta prime right there. Okay. If you're in quadrant 4, again, straight to the x-axis at a right angle, that would be x, that would be r, or y, that would be r like that. So the reference angle is always an acute angle that's measured between the x-axis and where the original ray terminates. Okay, and then you want to know how to compute those. There's a formula for each quadrant, but you don't need to memorize a quadrant. You don't need to memorize this stuff. You need to understand it and just figure this stuff out as you go. All right, so let's go to the next page, and I'll crunch out a few of these things, show you how we do this then. Okay, so I've given you the formulas. You don't need to memorize these formulas. You just need to figure it out as you do these problems. So this shows you how to find the reference angle. There's a couple of things I want you to fill out at the top of the page here that are real important. So the value of a reference angle is always an acute angle. And an acute angle just means you're between 0 degrees and 90 degrees. So you're always going to get an angle between 0 and 90 when you find a reference angle. Okay, it's never negative, never bigger than 90. It's always within that range. So I'm going to show you how these formulas work, and we're just going to do one in each quadrant. Okay, so let's go ahead and just draw yourself a sketch of the 53-degree angle in standard form like we've learned how to do. So you shade the x-axis, you just estimate, okay, you're somewhere in there in quad 1, so this is quad 1. And again, what you do on the reference angle is you go straight down at a right angle, and then that angle right there would be theta prime. Well, that's 53 degrees. There isn't anything to calculate. So if you're given a quadrant 1 angle, then the reference angle is the same. Okay, there's no calculation to do on that if you're in quadrant 1. That's automatic. Okay. Let's do 130 degrees. Okay, so just sketch it. Doesn't have to be perfect. All that matters is you know you're in quadrant 2. All right, so just kind of draw a quadrant 2 angle. Now that would be theta equals 130 degrees. That's the original angle. So to find the reference angle, you go straight down to the x-axis, and then that's theta prime. Okay? Well, what would you do to figure that out? You don't have to look at the formula out there. What are you going to do? It's halfway around the circle, less 180, right? So what would you do? 180 minus 130 is how you figure that out. Okay? That's what the formula says in my notes above. So you just calculate this way. You just say 180 minus 130. So that would be a reference angle of 50 degrees. Okay? That's it. Okay? That's how you handle quadrant 2, all right? The next one's quadrant 3. So just sketch a quadrant 3 angle. And this one would kind of go pretty close to the y-axis, so it would go like this, okay? And again, angle theta is 260 degrees. Now, what I see students do wrong all the time is they want to draw to the y-axis. Now, what did I say to do? You always draw to the x-axis, okay? So don't make that mistake. So what you do to get your reference angle is you go straight up like that at a right angle, and then theta prime is that right there. Okay, so think about what you would do. It's basically, I look at it like this. Halfway around the circle's 180, okay? And then you've got 260, so what are you going to do? You're just going to find the difference between those two then. Okay, so you just do 260 minus 180, and then that'll give the reference angle on that, so that's what? That's 80 degrees. Okay, that's an 80-degree angle, all right? All right, so you got to subtract that in the right order, okay? And then the last one would be if you're in quadrant 4. So again, we'll do the same thing. Start there at the positive x-axis. You terminate somewhere in quadrant 4. And again, your reference angle is drawing straight up to the x-axis. Theta prime is that angle right there. So what would you do to figure that out? Yeah, you'd do all the way around the circle's 360, right? So it would just be 360 minus the 306.5, would give you that leftover reference angle like that. Okay, so again, you want to figure this out as you go instead of having to memorize all these formulas. So that would be 53.5 degrees. Okay, now I'm going to show you something on this that the reason that you learn about reference angles, and you don't have to do this on your calculator, I want you to just pay attention to this. So I just want to make sure I'm in degree mode. So let me just give you an example. So like if I did the sine of 306.5 degrees, I'll get a bunch of decimals on that, okay? And if I also did the sine of 53.5, I won't get quite the same answer because one of them's negative and one's positive. But forgetting about the negative and positive, they will always be the same for every trig function. So for instance, on the previous problem, I'll pick another trig function like cosine. So if I did the cosine of 260, I get an answer. And if I do the cosine of the reference angle, then I get the same numeric answer but negative. Now sometimes they're the same. It just depends on what quadrant you're in, but the thing is, you're going to find that a trig function is either plus or minus whatever it is in the reference angle. That's the idea. It could be the same or it could be off, okay? It would kind of depend on that, okay? All right, so let's do a couple of these in radians. Any question about what I did? Okay, again, you can look at these formulas if you have to, but I'd recommend you just figure it out, sketch a graph, understand what the reference angle is, and do the right calculation, okay? Okay, these are in radians, so what I would probably do on something like this is, to me, it makes a lot of sense just to convert these things to degrees. So I'm going to convert this to degrees like we've learned. So pi is 180, so I'm going to do 8 times 180 over 3. And then that will give me theta is 480 degrees. Okay, well that means it's more than one lap around the circle. So if I subtract 360, and this is the purposes of this is just to figure out, you know, how to graph that angle. So basically 480 minus 360 is 120. So if you graph this angle the way I showed you, okay, you'd start like this. You would go clockwise one complete lap, or counterclockwise one complete lap, and then 120 more. So that's where that angle would be located. So theta is 8 pi over 3. Okay, like that. All right. So we're in quadrant 2. And again, the reference angle we're interested in, you go straight down to the x-axis at a right angle. Theta prime would be that. Okay. So we're going to leave this in radians. That's the thing. So in degrees, what you would do is this. In degrees, you would just go halfway around the circle, 180 minus the 120, right? Okay. Well, if you want to keep it in radians, what is 180 degrees is how many radians? Pi, right? So what you want to do is theta prime is just pi minus 8 pi over 3. Or you can just get 60 and convert it if you want to. It's your call. Okay, so I'm going to do this. All right, so I'm going to get a common denominator. Remember, pi is 180 degrees. So I'd end up getting that. Whoa, oh, hold on. I can't do that. I can't do that. I need to go ahead and I need to do it this way, because you don't want a negative answer on this. So that's 60 degrees. How do you convert degrees to radians? What do you multiply by? Pi over 180. Okay, so we're just going to do it this way. Pi over 180. It's just as well to do these this way. And then that is 60 pi over 180. That reduces down to pi over 3. So you want to reduce your angle then like that. Okay, so on these it's just as easy to convert those to degrees and then work with it that way. Okay, so this one I'm going to do kind of the same way. I'm going to take 25 times 180 over 6, and that will give me theta is negative 750 degrees. Okay, so what I would do with this one is, if it's negative 750, if you add 360, then it's negative 390. If I add 360 again, then it's negative 30. So the way I look at this problem is kind of like this. This is the same thing as 2 times negative 360 plus a leftover negative 30, right? Okay, so how many laps around the circle? 2 clockwise, and then the leftover negative 30. So the way this would graph out is like this. Okay, you would start there, you would show that you're doing 2 complete laps clockwise, then 30 more. So you're in quadrant 1, or quadrant 4, and then that would be your extra 30 degrees. So it would go like this, go straight up to the x-axis, that would be theta prime. Okay, well, that's 30 degrees, isn't it? Okay, we just went an extra 30 degrees when we did that. All right, so then what we're going to do is just convert 30 degrees back to radians, if I want it in radians, and you can reduce that fraction to pi over 6. Okay, now it's positive pi over 6. Reference angles are always positive. Okay, so if you get to more than 1 lap around the circle, it's still the same thing. Figure out where you terminate and figure out whatever that calculation is. Okay, does that make sense what I did? Okay, so I just did 2 laps and 30 more, and that's what that reference angle is. The reference angle is always the distance between the x-axis and where you terminate. Okay, same thing on here. It's the distance between the negative x-axis and where you terminate. Okay, that's it. If you know that concept, then you can always figure out what you do. All right, any questions about what I did on that? Okay, all right. So you want to try to be able to figure those out. The formulas, quadrant 2 is you're taking from 180. Quadrant 3 you do backwards. Quadrant 4, I think of it as 1 lap around the circle less that reference angle like that. Okay. Okay, let's go ahead and take a short break here. And then the next part of this, we'll get back, we'll work. On the third part, we're going to determine where the trig functions are positive and negative. Now, this is stuff that, again, you can memorize or figure out. Okay, I always vote for figuring out because there's so much stuff in trigonometry to remember. I don't want to just memorize it. So what we're going to do is I'm going to show you in each quadrant whether the trig function is positive or negative and show you a real quick, easy way to figure that out in your head. I know a couple of mnemonic devices that help you with that too. So the idea is if your angle is in quadrant 1, x is positive, y is positive, and r is always positive. R is a radius, so r is always positive. Okay, so the idea is this. It's just basically the sign, and you don't have to write all this down necessarily. The sign's y over r, so that would be a positive over a positive, so it's a positive. Okay. If you go through and do your definitions, you're going to find that everything is going to be positive in here then. So I'm going to do this kind of like this. The sign would be y over r, so that's positive. If the sign's positive, so is the cosecant, because they're reciprocals of each other. Okay? The cosine is x over r. X would be positive, r would be positive, so that's positive. And the secant is also positive. By the same logic, the tangent is y over x, so it's positive, so is the cotangent. So what you learn is if you're doing a trig function of a quadrant 1 angle, it's always a positive answer. That's all that is. So like for instance on the calculator, I could randomly pick any trig function, put in a quadrant 1 angle like 25 degrees, I'm guaranteed to get a positive answer. Okay, always. You're going to find that what's going to happen is each trig function is going to be positive in 2 quadrants and negative in 2 quadrants. That's how that goes. Okay, now if we go to quadrant 2, you have a point over here somewhere. X is negative, y is positive, r is always positive. You're just moving to the left, so x is negative, and you're moving up, so y is positive. Okay, well the sign's y over r, so that would be positive over positive, so that would be positive. Okay, the cosecant is also positive since it's the reciprocal of the sine. The cosine is x over r, so it would be negative over positive, so it's now negative. And then the secant has to be the same sign as the cosine, so it's also negative. The tangent's y over x, so y is positive, x is negative, so it's negative, and then the cotangent's negative. Okay, so here's kind of what you get is when your angle is in quadrant 2, the sine and cosecant are positive, cosine and secant are negative, so are the tangent and cotangent, like that. Okay, so just as a quick example, if I was to go through and do the sine of 120 degrees, that's a quadrant 2 angle, I get a positive answer. If I do the cosine of a quadrant 2 angle, I get a negative answer. And the same thing would happen if you did the tangent of a quadrant 2 angle, you would be guaranteed to get a negative. Okay, you guys understand what I'm trying to show you? Okay, the answer is either negative or positive. It depends on the quadrant. Okay, if you go to quadrant 3, remember you have a point over here. X is negative, y is negative. R is always positive. So you do the same kind of thought process. The sine is y over r. Okay, so that would be negative over positive, which would be negative. So you're going to find the cosecant and the sine are negative in quadrant 3. Cosine is x over r. X is negative. R is always positive, so that's negative. So you're going to find secant and cosine are negative in quadrant 3. And then the tangent is y over x. So y is negative. X is negative. A negative divided by negative is a positive. Okay, so what you end up getting is this then. So if you're in quadrant 3, the sine and cosecant are negative, so are the cosine and secant. And then the tangent is positive in quadrant 3, like that. Okay, and then if you move to quadrant 4, you have a positive x and a negative y, and r is always positive. So it's going to go like this. The sine's y over r, so that's negative over positive is negative. Cosecant's also negative. Cosine's x over r, so that would be positive over negative is negative. So the secant's negative. Okay, like that. Whoops, that's wrong. The cosine is positive in quadrant 4 because r is positive. Okay, so we'd have positive over positive, like that. And then what will happen on the tangent, since it's y over x, that would be a negative y and a positive x. That would be negative, so it would go like that. Now, there's got to be a quicker way to do this, and there is. I'm going to show you a couple of real easy ways to put this together. But you have to know in every quadrant whether the trig function is negative or positive. That's one way to figure that out. So there's a couple of ways that you can learn this. I'll show you one way. I think I have this on the next page. But one way you can do this is if you're in quadrant 1, everything is positive. If you're in quadrant 2, it's the sine and cosine that are positive. Okay, this is this little mnemonic device that a lot of times teachers teach. So S is positive, the sine's positive. If you go to quadrant 3, it's the tangent that's positive. So we do this, take, and then if you're in quadrant 4, it's the cosine. So they have this little mnemonic device you can use also. All students take calculus. What it means is everything's positive in quadrant 1. Quadrant 2, it's the sine that's positive, and it's reciprocal, but everything else is negative. In quadrant 3, take is the tangent, and then quadrant 4, C is the calculus. So what's positive in quadrant 2 is sine, and then tangent in quadrant 3, and then cosine in quadrant 4. So you can do that if you want to. Okay, that's not the way I do it. I'll show you how I figure this out on the next page. Okay, right, so that's information that you want to know. Okay, here's how I figure this out. Now, this is what I do. Okay, to me, this is the simplest thing I've come up with anyway. Okay, first of all, the sine and cosine the sine and cosecant depend on y values. Okay, so where is y positive? The sine is positive where y is positive. Where's y positive? Up there, right? Okay, so what you would find is the sine is going to be positive where y is positive, so that would be quadrant 1 and quadrant 2, like that. Okay, that's how I think of it. Okay, the cosecant, I keep saying the wrong trig function. The cosine is x over r. The secant is r over x, so it's all about x. So where is x positive? X is positive that way, okay? All right, so that would be 1 and 4. so it would be to the right. So just think of the sine being positive there, up, and then the cosine being positive there, okay, like that. And then the tangent is where they have the same sign. So if you're in quadrant 1, both x and y are positive, but if you have in quadrant 3, they're both negative. So the tangent's going to be positive in quadrants 1 and 3. It's just because it's y over x. So you either have a positive over a positive or a negative over a negative. Here's another one I found on the internet. All science teachers crazy. There's all kinds of them out there that I've heard. Okay, so whatever you need to know to work that out, be sure that you know how to have a way to figure out which quadrant each trig function is positive and negative. Okay, I think of this sine is there, positive there, cosine is there, tangent's like this. Okay, so where it's positive. If you remember that, then you got it made. Okay, all right. So what I'm going to do on at the bottom of the page here, this is something that a lot of times you have more than one condition and you want to figure out what quadrant you're in. So let me show you how I figure this out. This is usually what I teach students to do, is just draw a little diagram on this. So first of all, I'm going to put a check mark wherever the sign is positive. Okay, what did I say the sign is? The sign's a y value. It's positive up there. So the sign is going to be positive in 1 and in 2. That's where that happens. Okay, and then the cosine is negative. Okay, the cosine is an x value, so the cosine's negative that way. X is negative that way. So what I'll do is I'll put a check mark there and I'll put a check, whoops, put that in the wrong place. So the cosine is negative here and there. Okay, so sine's positive in 1 and 2. Cosine is negative in quadrants 2 and 3, so therefore we're in quadrant 2 because that's where they both overlap. Okay, that's just a way that I teach students how to figure that out. You can do that in your head. That's a good way, good approach is just figure out where the two check marks overlap. Okay, all right. On this one, I'll do exactly the same process. Okay, so the tangent is negative. I'll use a red check mark where the tangent's negative. The tangent's negative in 2 and 4. Okay, and then I'll do something for the secant. Okay, the secant is negative. Remember, the secant's r over x, so it's negative where x is negative, which would be there and there. Okay, so again, this would end up being quadrant 2. Okay, they're always going to overlap in one quadrant when you have two different conditions like that. Okay, okay, and the next one, I'm going to go like this. Okay, cosecant positive. Remember, the cosecant's r over y, so that's going to be positive above the x-axis. Okay, that's the two quadrants where cosecant's positive. Then I've got cotangent negative. Cotangent's going to be negative here and there. Oh, it turned out to be quadrant 2 again. I kind of could have come up with better examples, but that doesn't matter. Okay, it's always going to end up in one of the quadrants, and that's just a good approach to doing that then. Okay, does that make sense what I did? Okay, now as you're learning this, you want to get to where you know pretty quickly what the two quadrants, each trig function's positive and negative in, and then you can figure out if you have two conditions, what quadrant you're in. That's just what I do. Put two check marks in the first condition, 2 in the second, and wherever they overlap is where you are. Okay, that's an easy way to kind of put that together. Okay, any question about what I just did? Okay, that's just one way to show a student how to do that. So what we'll do next here, and we're going to learn how to do this in a faster, maybe a little bit more efficient way in the next section when we do the unit circle, which we're going to start on today. We're going to actually find the 6 trig functions at 225 degrees. Okay, and back when I took trigonometry, nobody even talked about the unit circle. I think that kind of idea came a little bit later. We're going to go ahead and graph 225. So we know that's in quadrant 3, so just kind of sketch a 225 degree angle. So that would be my angle theta is 225. And what I want to do is we're going to do a reference angle. So remember the reference angle, you always draw straight up to the x-axis, and then theta prime is going to be that reference angle right there. Okay. Well, how would you compute the reference angle? What would you do? It's in quadrant 3, so what do you do with the 225? Subtract 180, exactly. Okay, so what you're going to do is you're going to do 225 minus 180 degrees, and you'll find that to be 45. 45 is a special triangle. So in 5.3, the video I wanted you to watch on that talks about those special triangles then, okay? So if you haven't watched that, then you're not going to know exactly what I'm doing here. We're going to learn a totally different way to do this. So that reference angle is 45, and then that causes this to be a 45-45 right triangle, okay, like that. What you want to remember is, and if you look over my video in 5.3, it basically goes over this. The 45-45 right triangle, the sides can always be broken down into 1 square root of 2. Okay, so it goes like this. This x value would be -1, and that's -1 because you're in quadrant 3. And then opposite the 45 is also 1, but it's a y value, so that's -1 like that. And then this r value is square root of 2. So if you have a 45-45 right triangle, then the sides go 1 square root of 2. Okay, like that. Okay. Now we've got everything that we need to know to figure this out then. Okay, so if we're going to do the sign is y over r. So y is -1, r is square root of 2. Okay, so you can rationalize that denominator to get negative square root of 2 over 2 like that. Okay, and that's how that goes. Okay, the cosecant is r over y, so that would just be square root of 2 over -1, so that's negative square root of 2. Okay, and notice that we're in quadrant 3, so the sign's negative. Okay, we expect the sign to be negative in quadrant 3. Okay, then I go to the next thing. The cosine is x over r. X is -1. R is square root of 2. Again, you rationalize the denominator. You get negative square root of 2 over 2. So the cosine also, for a quadrant 3 angle, is negative. Okay, and then the secant is r over x. R is square root of 2. X is -1. So that's negative square root of 2 like that. So the sine and cosine turned out to be the same in this problem because it's 45 degrees. Remember, sine and cosine are cofunctions, and 45 and 45 are complementary angles, so we expect them to be the same. Okay? And then finally, the tangent's y over x. Y is -1. X is -1, therefore that's 1. Cotangent's x over y, so it's the same answer. That'd be +1. So you can use a reference angle to figure this out then. Now, all these things are checkable on a calculator. I'll just kind of check one of these. They're all checkable. So if you were to do the tangent of 225 degrees on your calculator in degree mode, you get 1. So they're all checking and verifiable. If I did the sine of 225, that will give me a bunch of decimals, but I could just take my answer, which is negative square root of 2. Whoops. Try it again. So let's see. Sine of 225 gives this, and then negative square root of 2. I did the same thing. Okay, so negative square root of 2. And then over 2. I'm just showing you can tell you're right on these problems. Your calculator will give you a way to tell you're doing this correctly. Okay, so they're all checkable. So the key thing on this is find your reference angle, apply this triangle. All these problems I'm giving you are going to have reference angles that are 45, 30, or 60. So they go along with the special triangles. Okay, next problem goes like this. Let's again plot this out. You're in quadrant 4. Okay, so just sketch out a quadrant 4 angle like that. Okay, and then the reference angle is right here. That's theta prime. Okay, what would you do to find the reference angle if it's 330? You can do this in your head. What would you calculate? 360 minus 330. Okay, so that's going to give you a 30-degree reference angle like that. Okay, All right, now this is the kind of stuff that you learn in 5.3, so you need to watch that video and go over that. So this would be what we call a 30-60 right triangle. And the 30-60 right triangle goes like this. Opposite 30 is 1. Opposite 60 is square root of 3. The hypotenuse is 2. Okay, now we're not going to use reference triangles very much once we learn the unit circle. So it goes like this. The y value would be -1 because it's opposite 30. The x value is positive square root of 3. X is positive if you're moving to the right. And then r is going to be 2. So from there, you can figure these things out real easily then, okay? So what we get is the sine is y over r. So y is -1, r is 2. So the sine would be -1 over 2. Okay, the cosine's x over r. X is square root of 3, r is 2. So that would be square root of 3 over 2. Okay, tangent's y over x. Y is -1, x is square root of 3. Rationalize the denominator to get negative square root of 3 over 3 like that. Okay, and then you can do the reciprocals to get the other values like this then. Okay, so then the cosecant is r over y. R is 2, y is -1, so that would be -2. The secant is r over x, so that would be 2 over root 3. Rationalize to get 2 root 3 over 3. The cotangent's x over y, so that would be root 3 over -1, so that's negative square root of 3. So what you're doing is you're applying your definitions based on that triangle. And these problems are designed so the reference angle is 30, 60, or 45. And you want to know these two triangles to do this. However, once we get in the next section, you can get by with this, but you always got to show students where the unit circle comes from, because it's going to speed up the process and make these problems go a lot faster. Okay, and that's what we're getting to. Okay, all right. Okay, so let's do one more thing here, a couple of things to kind of finish this up, because I do want to get into the unit circle here a little bit. Okay, this one, to me, if you're doing a problem like this, it's just as well to go ahead and change it to degrees. So pi is 180. And you can take your calculator on that if you want to, but 2 times 60 is 120 degrees. So we're looking at a 120 degree angle. We're going to find the trig functions of 120 degrees. So there's my positive x-axis. I know I'm in quadrant 2. And once you get kind of the handle on these reference angles, you'll start doing a lot of them in your head or just kind of quickly in the calculator. What's the reference angle in your head? 60. Okay, good. Yeah, so you're just doing 180 minus 120 to get 60 degrees. Okay, so again, what you're going to have is you're going to have the triangle. It goes like this. So it's a 30, 60 right triangle. And the sides go like this. Opposite 30 is 1. Opposite 60 is square root of 3. Opposite 90 is 2. But you want to make sure you tie in the negatives. So x would be -1 since you're moving to the left. Y would be positive square root of 3 since you're up. And then r would be 2. Okay, so be sure that you pay attention to the signs on that. Okay, that's all the same. The sign is y over r. So that would be square root of 3 over 2. That gives that for us then. The cosine is x over r. So that would be -1 over 2. The tangent's y over x. So y is square root of 3. X is -1. So that's negative square root of 3 like that. Okay, then it's just a matter of doing the reciprocals. Cosecant's r over y. So that would be 2 over root 3. That rationalizes to 2 root 3 over 3. The secant's r over x. R is 2, x is -1, so that's -2. Cotangent's x over y. So that would be root 3, -1 over square root of 3. And then that would rationalize to negative square root of 3 over 3. Okay? So basically, once you figure out your reference angle on that reference triangle, then it's just a matter of using the definition to plug in and just doing the rationalizing and that kind of thing. Okay? Is everybody with me okay? Okay? So you want to get those triangles kind of memorized. Like I say, well, you'll get away from that, as soon as I finish this section and begin to teach you the unit circle, and you can do these things like real super fast by looking at the unit circle. Okay, let's go to the next page. And what I want to do on the next page is go ahead and we're going to do what we call quadrantal angles and do this. A lot of these special angles you want to be able to figure out in your head, so you don't have to use a calculator all the time. So a quadrantal angle is just you're on an axis. So it's like 0, 90, 180, 270, and so forth like that. Okay, in radians, it goes 0, pi over 2, pi, 3, pi over 2. It goes by pi over 2s. So what we're going to do is just figure out the 6 trig functions at 0, 90, 180, and 270. Okay, so the way you would do this, if you draw a 0-degree angle, well, you'd be on the x-axis. Okay, but you go like this. You just let r be 1. You can actually let r be anything you want to, but 1 is simplicity. Okay, so what you would have is this point would be the point 1, 0. So you would end up having r is the radius of that circle. You got to understand that you always kind of have a circle going around your point when you're talking about trig ratios. So x would be 1, y would be 0, like that. Okay, I'm just letting r be 1 for simplicity. If you let it equal 2, then x would be 2, and the ratios would be the same anyway. Okay, so then it goes like this. The sign would be y over r, so that would be 0 over 1. So the sine of 0 degrees would be 0. Okay, all right. And let's see, the cosecant is going to end up being r over y. So r is 1, y is 0. What do you know about 1 over 0? It's undefined. So you're going to find that the trig functions sometimes are going to be undefined at certain quadrantal angles. Okay, the cosine's x over r. X is 1, r is 1. Therefore, the cosine would just be 1. Okay, the secant's r over x. R is 1, x is 1, so that's equal to 1. So we have the sine and cosecant, we have cosine and secant. That's how you figure that out. Okay, the tangent is y over x. So y over x would be 0 over 1. That would be 0. The cotangent is x over y, so 1 over 0 would be undefined like that then. Okay, so that's how you figure that out. Again, you're just applying the definitions. If you know that the x, y are definitions, you plug in. You just need to know what x, y, and r is in order to figure out the value of your trig function. Okay, okay, let's go to the next one here, 90 degrees. So 90 degrees, again, you have a point, and that point's going to be 0, 1. So we're going to let r be 1. X is going to be 0, y is going to be 1. Okay, and it just goes like this. So the sine is going to be a y over r. So y over r would be 1 over 1 would be equal to 1. Cosecant is the reciprocal of 1, so it's also 1. Cosine's x over r. So that would be 0 over 1. So that would be 0. The reciprocal of 0 is undefined, so the secant's undefined. Okay, tangent is y over x, so y is 1, x is 0, so that would be undefined. Cotangent is x over y, so that's 0 over 1, so that's equal to 0. And you'll start seeing a pattern on this. You're going to start seeing you'll have 2 1s, 2 0s, and 2 undefineds if you're on a coterminal angle. Although sometimes the 1s can be negative. Okay, so that's how that goes. Okay, let's do 180. This is important enough to go through each one. So if you're at 180 degrees, the point is -1, 0. R is 1. So now x is -1 and y is 0. Okay, now I'm just going to kind of quickly write what these are. The sine is y over r. So that's 0. The cosecant is the reciprocal of 0, so that's undefined. The cosine is x over r, so that would be -1. The reciprocal of -1 is -1, so the secant's -1. The tangent's y over x, so that's 0. The cotangent is the reciprocal of 0, so that's undefined. Okay, so you end up getting these values. Notice you have 2 zeros, 2 undefineds, and 2 -1s. Okay, that's the pattern. That's the way it always works out. Okay, everybody with me okay, what I'm doing? Okay, because you're going to do this, throughout the rest of the semester, so you want to be able to figure this out. If you're in calculus, you don't want to go fumbling for your calculator all the time. You're just going to have to know what the trig functions are at special angles and be able to have a quick way to figure that out. Okay, so I'm going to go ahead and run through this next page. I want to do 270, and I want to just close off kind of with one additional example. So if you're at 270, the point you're interested in is the point 0, -1. So you're down 1. So r is 1, x is 0, y is -1. Okay, so it goes like this. The sine is y over r, so that's -1. The cosecant is also -1 since it's the reciprocal of the sine. The cosine is x over r, so that's 0. The secant is the reciprocal of 0, so that's undefined. The tangent's y over x, so -1 over 0 is undefined. The cotangent is x over y, so that would be 0 over -1, so that's equal to 0. So again, same pattern, 2 -1s, 2 zeros, 2 undefineds. What you have to know is know your definition and be able to figure that out. All you do on most trig functions is it all becomes, do I know x, y, and r? Do you know x, y, and r, you got it made. Okay, that's what it's all about. Okay, so let's do this last example here. This is just sort of an exercise to help students get their definitions down. So what I've done on this one is I've given you a trig function and I've given you a condition. That's enough information to figure out the rest of the trig functions. So the first thing I'm going to do is we're going to figure out what quadrant we're in. Okay, so I'm going to kind of do this like I showed you before. So the tangent is negative. I've given you a negative tangent. The tangent's negative in quadrants 2 and 4. Okay, until you get that memorized, you can look that up if you need to. The sine is negative down below, so there and there. So that means that we are in quadrant 4. So anytime I give you a trig function and another piece of information to narrow the quadrant down, then you want to do that. So if you're in quadrant 4, x is positive, y is negative, and r is always positive. You always got to get those signs down. Trig is real picky about signs, so it's real common when students work homework out, they're off by a sign. Okay, because you got to pay close attention to what you're doing on that then. So that's kind of the first thing you do is figure out the quadrant. The second thing is, again, if we can figure out x, y, and r, we got it made. Okay, well the idea is the definition of a tangent is y over x. So I did give you y and I did give you x. Okay, so that means that y is -5, x is 12. Since we're in quadrant 4, that's why y is negative. Okay, do you guys know what r is in your head? This is one I want you to try to memorize. It's a Pythagorean triple, 5, 12, 13. If you don't know that, use the Pythagorean theorem, but I'm not going to do that part. That's a Pythagorean triple. Work it out, you'll get that. Okay, that's it. So really the work of the problem is figuring out x, y, and r. Now from here, it's easy. So the sine is y over r. So that would just be -5 over 13. The cosecant's the reciprocal, so that's -13 over 5. The cosine's x over r, so that's going to be 12 over 13. Secant is the reciprocal of the cosine, so 13 over 12. Tangent's y over x, so that's -5 over 12. Cotangent's the reciprocal, so it gives that. Okay, so think of these problems if I'm asking for the 6 trig functions. Figure out x, y, and r. That's what you have to do, and once you realize that's all you're doing, then it's pretty easy to do. But be real careful about those signs when you're doing this. Make sure you know what quadrant you're in. Okay, is there any question? Is that what I did there? Yes, no? So far? Okay, all right. Okay, one thing about